my dear students, welcome back to our channel. My name is Prachi and today we will be starting with hydrogen chloride, that is the 8th chapter from the book. If you have not covered it yet, if you are scared of the equations, you don't want to learn them, today is the day that you start with it. So let's get into the video right away. Alright students, I hope you can see my screen now. So we'll begin with the basic introduction of hydrogen chloride. So what is the basic formula? So that is HCl. What kind of form HCl forms? It forms a covalent bond. And how does that form that? Your hydrogen atomic number is 1. Chlorine atomic number is 17, which breaks down to 287. So it is easily able to share one electron pair and satisfy its valency. Since it is forming a covalent bond, it can also be represented as H, a single dash, and Cl. This is a representation of a covalent bond. Now, HCl is also known as a polar covalent bond. Now, why does that happen? That is because of the high electron negativity of chlorine. Due to its high electron negativity, you can note it down that chlorine ends up pulling the electron pair, the shared pair, slightly towards itself. And when that happens, chlorine gets a slight negative charge and hydrogen gets a slight positive charge. Therefore, because of the movement of the electron pair towards any one atom, it is known as polar covalent compound. So I'll write it here. It's polar covalent compound. Now, if we think about the occurrence, so in what forms can HCl occur in nature? So, occurrence. The first thing is that it can occur as an acid or it can occur as a gas. So you can have HCl gas or you can have HCl acid. It can occur in both the forms. The second is it can naturally occur or it is found present in volcanic eruptions. So present in volcanic eruptions. Other than that, it is also present in mammals, in gastric juices. So as a gastric juice, HCl acid is present in mammals, so digestive system. When we'll cover that, you'll understand more about it. Then, other than this, it is also known as muriatic acid. That's another name given to it. And in the exam, they can, for one-word answers, for multiple choice questions, they can give you the name of the acid. Like, for example, they'll give you muriatic acid and they'd ask you, what is this? And then they'll give you options like sulfuric acid, HCl, and then you'll have to mark. So you need to know all the possible names or all the name given to any acid. Alright students, moving on to preparation. So one thing to remember for preparation is that you always prepare HCl as a gas. You do not prepare the acid directly. Once you have the gas formed, then you combine it with water and get HCl acid. How we mix it, we have a whole process for that and we will be covering that in the upcoming parts. For preparation, we have two types of preparation. One is the general preparation and one is the lab preparation. Right now, we are starting with the general preparation. So, general preparation. In general preparation, we have two methods. The first method is direct combination. This is also known as synthesis reaction. In synthesis, what we are doing is we are directly combining hydrogen gas with the chlorine gas and we are getting 2HCl. This reaction can specifically happen in diffused sunlight. This question can be asked, why only in diffused sunlight? So the basic reason is that if you have a dark room, then the reaction is negligible. If you have direct sunlight, In that case, this particular reaction can be extremely explosive. So why diffuse sunlight? Because if we have a dark room, the reaction is negligible. We do not really get a lot of amount of HCl gas in that. If we have direct sunlight, in that case, this particular reaction is explosive. But if you can use a catalyst, that is activated carbon, if we use activated carbon as catalyst, in that case, this reaction can happen, because activated carbon will speed up the process of this reaction. Hence, you can have direct combination in a dark room if you're using activated carbon as a catalyst. Moving on to the second method of preparation, that is reaction with metal chlorides. With what? With concentrated H2SO4, concentrated sulfuric acid. So we'll look at the first reaction. So you have NaCl plus H2SO4 at a temperature lower than 200 degrees Celsius, you get NaHSO4 plus HCl. The same reaction can happen above 200 degrees Celsius plus H2SO4, 200 degrees Celsius. This gives us Na2SO4 plus HCl. Now, both of the acids are concentrated in both of the equations. So what is happening here is that you have NaCl, you are combining it with H2SO4, and you end up getting HCl as the byproduct, HCl in the products. Now, there is a reason why we always prefer the first reaction, and we will do that after the lab preparation we have studied. So for now, you can only understand that you have NaCl, it combines with concentrated H2SO4 and gives you NaHSO4 plus HCl. At above 200 degrees Celsius, it is giving you Na2SO4 plus HCl. Now, if you take up another example of your metals or metallic chloride, you can take CuCl2 plus H2SO4 will give you CuSO4 plus HCl. If they ask you a question in general preparation, you can use any metallic chloride and you can react with H2SO4. So you don't specifically have to learn these equations. Okay, the important equation that you do have to learn is this one. These two equations are important. For the other example, for example in general preparation, if you want, you can use any other metal chloride with H2SO4. But when it comes to lab preparation, you can only use NaCl. That is because NaCl is cheap and it is readily available. Hence, we use NaCl as a reactant when it comes to lab preparation. But in general equations, you can write anything you like. So students, this is where we conclude the first part of this chapter. In the next part, we will be working on the lab preparation of HCl. How do we collect it? What are the precautions we take? What are the conditions that we need specifically for this preparation, and completely about what apparatus we are using. So we will be going in a lot of detail and what kind of questions we can expect from that part. So please like, share, subscribe, and if you have any doubts about it or any particular part you would like me to cover, please mention that in the comment section. Thank you so much.